Hello guys, welcome to Monday Night Physics. So we are going to be solving a problem for this Monday. It reads, a motorcycle stunts rider moving horizontally takes off from a point 1.25 meters above the ground. He lands 10 meters away from the takeoff point as shown in figure 2. What is the speed at takeoff? So we have 5 meters per second, 10 meters per second, 15 meters per second, and 20 meters per second. So if you solve the equation successfully, then stay tuned for the solution. Alright, so this is projectile motion, alright, motion in 2 dimensions. As the rider is following this path, it covers a horizontal distance of 10 meters and a vertical distance of 1.2 meters. Alright, so we are going to use that concept to be able to get the speed at takeoff. Now it should be noted that when it takes off, it is actually taking off in the horizontal direction. So the initial velocity or the initial speed in the vertical direction is 0. Alright, now we are going to use the fact that we have S is equal to ut plus half at squared. Now if it covers a horizontal distance of 10 meters, okay, so I'm just going to call Sx for the horizontal distance covered equal to ux times t plus half ax times t squared. Now it should be noted that in the horizontal direction there is no acceleration, so ax is equal to 0. Now ux is the initial speed in the horizontal direction, which is actually what we are finding. So from here, and t is a time of flight, that is the time taken to cover 10 meters horizontally or 1.25 meters vertically. So we are going to have that the horizontal distance is just equal to the initial velocity in the horizontal times the time taken to cover that horizontal distance. Now we have the horizontal distance as 10. We don't have the initial velocity in the horizontal, which is what we are looking for, and we don't have the time of flight, so we are going to also find the time of flight. Now if we consider motion in the vertical direction, Sy will be equal to uy times t plus half ay times t squared. Now this t does not change because the time taken to cover 10 meters horizontally is the same time taken it uses to cover the vertical distance of 1.2. Alright, so the time of flight is the time taken to move from this position right up till this position, and that time taken is equivalent to the time taken to cover 1.25 meters vertically. Also, it is equivalent to the time taken to cover the 10 meters horizontally. Alright, so in the vertical direction, the acceleration here is actually the acceleration due to gravity. Alright, and since it is moving downwards, then actually it is in the direction of g. Therefore a here is going to be positive 9.8 meters per second squared. If it was moving upwards, then it's moving against gravity, so ay is going to give us negative 9.8. But since it is moving downwards, then it is moving in the direction of g. Alright, so from here, what do we have? We have that the vertical distance covered is, now since it actually took off horizontally, alright, it therefore means that the initial velocity in the vertical direction is 0. So we just have half times your ay here is 9.8, then times t squared. So from here we can be able to find t squared, and t squared is just going to give us, now if we perform this, we have 4.9. Sy is actually 1.25, that is the vertical distance. So we have 1.25 divided by 4.9. So to get the time taken to cover that distance, we just take the square root. So this time is equal to the square root of 1.25 divided by 4.9. So if I punch on my calculator, you guys should just give me some few minutes so that I should compute the value. So if we take the square root of 1.25 divided by 4.9, we actually have 0.50, approximately 0.501. Oh, in fact this gives us 0.501 seconds. That is a time taken. Okay, now since we need the initial velocity of takeoff, at takeoff, ux from our first equation there is sx divided by t, which is going to give us, now what is sx? 10 meters. What is t? 0.5, sorry, I made a mistake, 0.505. So this is actually going to be in meters per second at the end of the day, because the numerator is in meters and the denominator is in seconds. So if I punch, that is 10 divided by 0.505, I have 19.8, and 19.8 will actually give us approximately 20 meters per second. Alright, so with that we are going to have approximately 20 meters per second. Hopefully, if we actually use our g here to be 10 meters per second squared, then we are going to have exactly 20. Or if we just maybe kept this at 0.5, we have exactly 20 meters per second. So for those of you guys who had 20 meters per second, congratulations, you have scored the points for Monday night physics. Alright, see you guys for Tuesday night mathematics and the rest of the days. Make sure you subscribe to our YouTube channel, you turn on your notifications so that when subsequent videos are uploaded, you'll be notified to come and watch. Stay blessed and see you guys in the next video.